Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on vector space, lecture number 32, in which I will discuss First Isomorphism Theorem in linear transformation and basis of the quotient space. Now we will discuss about First Isomorphism Theorem on linear transformation. Statement: let T be a linear transformation defined on a vector space V into vector space V prime, and let W equal to kernel of T, then V by W is isomorphic to V prime. Now we prove this. Let V and V prime be two vector spaces defined on field F, and T is a linear transformation defined on vector space V to vector space V prime. Let W be the kernel of linear transformation T. Since W is a subspace of V, kernel of T is a subspace of vector space V. Therefore, V by W is the quotient space containing equivalence classes, equivalence class X, equivalence class Y, comma dot dot dot, where X, Y dot 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 belong to vector space V, and equivalence class X is the quotient of W, that is equivalence class X equal to W plus X. Let T bar be a mapping defined on V by W quotient space into V prime, such that T bar X class equal to Tx for all X belong to vector space V. This is number one. Let A, B belong to F field and X, Y belong to vector space V. Now T bar A X class plus B Y class, this equal to class AX and this equal to class BY. Here sum of two classes AX and BY is a class AX plus BY. From 1, here T bar X class equal to Tx, therefore T bar class AX plus BY equal to T AX plus BY. Since T is a linear transformation, therefore T AX plus BY equal to ATX plus BTY. Since Tx equal to T bar X class, here we write Tx equal to T bar X class, here Ty equal to T bar Y class. This is number 2. Therefore, we get T bar AX class plus BY class equal to A T bar X class plus B T bar Y class. That means T bar is a linear transformation. Now to show T bar is 1, 1, let T bar X class equal to T bar Y class. Since T bar X class means Tx from 1 and T bar Y class equal to Ty, implies that Tx minus Ty equal to 0 vector of V prime. Since T is a linear transformation, this means Tx minus Y equal to 0 vector. This means the image of x minus y is 0 vector of V prime. That is, x minus y belong to car T, kernel of T. Kernel of T is W. Therefore, x minus y belong to W. That means, according to our definition, x is congruent to y. That means x class equal to y class. Therefore, we get T bar x class equal to T bar y class means x class equal to y class. That is 1 1. This is number 3. From 2 and 3, we get that T bar is 1 1 and a linear transformation. That is, T bar is 1 1 linear transformation. Therefore, T bar is non-singular, implies that T bar is invertible, and that means T bar is 1 1 and onto linear transformation. That is, T bar is isomorphic mapping. Therefore, V by W is isomorphic to V prime. Proved. Now we prove a theorem. If W is a subspace of a finite dimensional vector space Vf, then dimension of V by W equal to dimension of V minus dimension of W. Now we prove this. Let Vf be n-dimensional vector space over the field F. Let W be a subspace of V such that dimension of W equal to M. Let the set S contains vectors alpha 1, alpha 2, alpha M, and this set be the basis of subspace W. Since S is subset of W and W is subset of V, implies that S is subset of V. Since S be the basis, therefore S contains m number of linearly independent vectors. That means S is a linearly independent subset of W. Here S is a linearly independent subset of V. By extension theorem, S may be extended to get a basis of vector space V. Let S1 be a set containing all elements of S and also some other elements alpha m plus 1, alpha m plus 2, alpha n. And let this is the basis of vector space Vf. This basis contains n number of linearly independent vectors. V by W is the quotient space which contains the classes x, y dot dot dot, where x, y all are elements of vector space V. And X class means quotient W plus X. Since we know that A multiply X class equal to a class A X class, and X class plus Y class equal to X plus Y class. The zero vector of V by W is zero class, that is equal to W itself. If X belongs to W, then X class is the zero class, and that is the W. Let alpha belongs to vector space V, then alpha can be expressed as linear combination of elements of basis of S1. S1 is the basis of vector space V. Therefore, alpha equal to A1 alpha 1 plus A2 alpha 2 plus dot 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 An alpha n. This is equal to sigma I equal to 1 to n Ai alpha I. Now we use the class in both sides. Left side alpha class, and in right side the class sigma I equal to 1 to n Ai alpha I. This means from 3 sigma I equal to 1 to n Ai alpha I class. We may take outside Ai here alpha I class. If we expand this, we get A1 alpha 1 class plus A2 alpha 2 class plus A3 alpha 3 class plus dot 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 AM alpha M class plus AM plus 1 alpha M plus 1 class plus dot 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 AN alpha n class. This is number 4. Since alpha 1, alpha 2, alpha m all belong to vector subspace W, if we take any element of W and make a class, then that class is the zero class, and that is equal to W. Therefore, alpha 1 class, alpha 2 class, alpha 3 class dot 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 alpha m class equal to zero class. Therefore, from 4 alpha class equal to this class is 0, this class is 0, this class is 0, we get am plus 1 alpha m plus 1 class plus am plus 2 alpha m plus 2 class plus dot 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 an alpha n class. Therefore, any element alpha class belongs to V by m can be expressed as linear combination of class alpha m plus 1, class alpha m plus 2, dot 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 class alpha n class. Let S2 is a set containing classes alpha m plus 1, alpha m plus 2, dot 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 alpha n. This is number 5. That is, S2 generates V by W. Let B m plus 1 multiply class alpha m plus 1 plus B m plus 2 class alpha m plus 2 plus dot 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 plus Bn class alpha n equal to 0 class. This is number 6. This means class B m plus 1 alpha m plus 1. This means class m plus 2 into alpha m plus 2 plus dot dot dot. This means class Bn alpha n equal to 0 class. And from 3, this equal to, we add this plus this and we make a class left side. This class equal to 0 class. That means these, some of these elements belong to W vector subspace. Since alpha 1, alpha 2, alpha m be the vectors of the basis of W, so any element of W can be expressed as linear combination of alpha 1, alpha 2, dot 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 alpha m. So this equal to C1 alpha 1 plus C2 alpha 2 plus dot 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 Cm alpha m. We take all these in one side. And this equal to 0. We know that alpha 1, alpha 2, alpha m plus 1, alpha n all belong to the basis of the vector space V, and these are linearly independent vectors. Therefore, we get C1 0, C2 0, Cm 0, dot 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 Bn 0. Therefore, from 6 and 7, we get Bm plus 1 class alpha m plus 1 plus Bm plus 2 class alpha m plus 2 plus dot dot Bn class alpha n equal to 0 class implies that Bm plus 1 equal to 0, Bm plus 2 equal to 0, dot 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 Bn equal to 0. This means that class alpha m plus 1, class alpha m plus 2, dot 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 class alpha n are linearly independent elements of V by W. In 5 also we have seen that S2 generates V by W, and from 8 S2 is a linearly independent subset of V by W. That means S2 be the basis of V by W. Since number of elements in S2 be the basis of V by W. Number of elements be n minus m. Therefore, dimension of V by W equal to n minus m. N be the dimension of vector space V and m be the dimension of subspace W. Therefore, dimension of V by W equal to dimension of V minus dimension of W. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.